Force and its effects. Learning objectives. Force, an introduction. Effects of force. Types of force. Coefficient of friction. Angle of friction. Other forces. Units of measurement. Spring balance. Force, an introduction. All the activities which involve movement of people or things require force. Definition of force. A force is defined as a push or pull that causes some kind of movement in an object. The force causes an object to move or to slow down, to stop, or to change the direction of the object's motion. Since any change in velocity is considered acceleration, it can be said that a force on an object results in the acceleration of an object or in deceleration if applied in the opposite direction of the movement of the object. The acceleration caused by a force depends on the mass of the object. Force is defined by Newton's second law as F equals m middle dot A, where F equals force, m equals mass and A equals acceleration. Let us see some examples of force in our daily life. Example 1. A heavy object on a table is pulled, attracted, downward toward the floor by the force of gravity, i.e., its weight. At the same time, the table resists, or push, the downward force with equal upward force, called the normal force, resulting in zero net force and it causes no acceleration. Example 2. If you go to the park to play football, how do you play? You move the stationary football with your foot by applying the force on the football. You also feel the opposite force or resistance of the football on your foot. Heavy object on a table pulling downward. Effects of forces. Force changes velocity. The force acting on an object will cause the object to change its velocity. That means it will start moving, increase its speed, decrease its speed, stop moving, or change direction. A change in velocity is defined as acceleration or deceleration depending upon in which direction the force is applied. Every force can have the same three effects on objects. Kicking football. Acceleration. A force can make an object go faster. Deceleration. A force can make an object go slower. Change of direction. A force can make an object start moving in a different direction. Change of shape. A force can change the shape of an object. 1. Force can make stationary object move. In general, most things are standing still and you will see things that were still suddenly start to move for one reason or another. For example, an apple falls from the tree to the ground. A vegetable vendor pushing his cart on the street. You blow up balloon, and it flies away as the air rushes out. You hold an inflated balloon underwater, it shoots up the moment you release it. There is a common factor in the motion of all above examples. In every case, a force was acting on the objects. Apple falling from the tree. Vegetable vendor pushing his cart. Blowing up balloon. 2. Force can stop or slow the moving objects. When you are riding on a cycle, you apply brakes to slow down or to stop. How this happens? The brakes applied pressure in the opposite direction of the movement making bicycle to slow or stop. While crossing the road, if you are accidentally being hit by a moving vehicle, you try to stop the vehicle by applying force in the opposite direction of the movement of the vehicle. In all these examples you have seen that if we apply force in the opposite direction of a moving object, it stops or slows the object. Boy applying brakes of cycle. 3. Force can change the speed of moving objects. A football player can change the speed of the ball by applying force and angling his foot. When he kicks the ball in same direction, the ball starts moving faster. When he kicks the ball in opposite direction, it slows down the ball and the goalkeeper applies force to stop the moving ball. Football player stops football by his foot. 4. Force can change the direction of moving objects. A batsman applies force by hitting the ball to change the direction of the ball. Similarly, a volleyball player changes the direction of the ball by hitting the ball to other direction. 5. Force can change the shape of the objects. When we squeeze a sponge, its shape changes. When we pull a spring, it gets stretched and its shape changes. In kitchen, when we apply force on dough, it gets converted to circular chapatis. Pulling spring. Making chapati. Squeezing a sponge. 2 classes of forces. Forces can be divided into 2 classes. 1. Contact forces. 2. Non-contact forces. 1. Contact forces. The contact forces are types of forces in which the two interacting objects are physically contacting each other. Those forces that act by direct contact, such as when you push a door to open it. Direct contact forces seem to make sense. It only seems natural that if a moving object smashes into another object, it will cause the second object to move in the same direction, as explained by Newton's laws. 2. Non-contact forces. The non-contact forces are the types of forces in which the two interacting objects are not in physical contact with each other, yet are able to exert a push or pull despite a physical separation. Examples of these forces include the following. Gravitational forces. For example, the Sun and planets exert a gravitational pull on each other despite their large spatial separation. Electric forces. For example, the protons in the nucleus of an atom and the electrons outside the nucleus experience an electrical pull towards each other despite their small spatial separation. And magnetic forces. For example, 2 magnets can exert a magnetic pull on each other even when separated by a distance of a few centimeters. Planets moving around Sun. Magnetic force. Direction of force affects motion. If an object is moving and you push it in a direction at an angle to what the object is traveling, the force of the push will cause the object to change its direction. Forces in a line add or subtract, according to their direction. For example, if one person pulls on a rope with a force of 12 pounds and another person pulls in the opposite direction with a force of 9 pounds, the total force will be 3 pounds in the direction of the 12-pound force. If several forces or velocities are applied at angles, it is not so easy to calculate the total force in a given direction. For example, calculating the total force in the direction of motion of a jet plane moving through a crosswind is much more difficult and complex. Types of force. Force exists in many forms like the Coulomb force between electrical charges, gravitational force between masses, magnetic force, frictional forces, centrifugal forces, spring force, magnetic forces, tension, chemical bonding and contact forces. Only 4 fundamental forces of nature are known: the gravitational force, the electrical force, the magnetic force, and the frictional force. All other forces can be reduced to these fundamental interactions. Let us discuss the different forces in detail. Gravitational force. Isaac Newton discovered that gravity is a force that acts at a distance and attracts bodies of matter toward each other. The force of gravity from the Earth on an object is the acceleration of gravity times the mass of the object, which is equal to the object's weight. The law of gravity determines how fast objects will fall. It is the gravitational force between the Sun and the Earth which holds the Earth in its orbit around the Sun. Force proportional to mass. The amount of matter in an object is called its mass. The force of gravity is dependent on the amount of mass a body has. That means that the gravity on the Earth is greater than the gravity on the Moon, since the Earth has much more matter or mass than the Moon. Gravitational force. Weight is measurement of force. The force of gravity on an object caused by the mass of the Earth equals the mass of the object, m, times the acceleration caused by gravity, g. The equation is F equals mg. Universal gravitational law. The universal or standard gravitational law states that the force of gravity between two objects is proportional to the product of the masses of the objects and inversely proportional to the square of the distance between them. Electrical force. A well-known fact of electricity is that two similar charge, whether positive or negative charge, repel each other. A positive charge and a negative electric charge always attract each other. Electric charge is a fundamental conserved property of some subatomic particles, which determines their electromagnetic interactions. Electrically charged matter is influenced by, and produces, electromagnetic fields. The interaction between a moving charge and the electromagnetic field is the source of the electromagnetic force, which is one of the four fundamental forces. Activity 10.1. Aim. To show that electric force attracts small pieces of papers. Material required, plastic scale, small pieces of papers. Method, take a plastic scale and small pieces of paper. Rub one end of ruler on the dry hair or on woolen pullover and then keep the rubbed end to small pieces of papers. You will observe that the paper pieces cling to the plastic ruler. Conclusion. The paper pieces cling to the ruler because ruler gets electrically charged when rubbed with hair or wool, which attracts the paper pieces. This shows that electricity is a kind of force. Plastic scale. Small pieces papers. Tabletop. Magnetic force. For long this has been noticed that some substances attract iron or steel objects towards themselves. Even when you place substances like iron, steel, cobalt in a coil carrying electric current, they also get attracted towards the coil. This property of attracting substances made up of iron, steel, cobalt, etc. by certain substances is called the magnetic property. The substance having this property is called a magnet. One of the characteristic features of magnets is that similarly charged poles repel and opposite charged poles attract. Magnetic field is that part of the electromagnetic field which exists when there is a changing electric field. A changing electric field can be caused by the movement of an electrically charged object, as in an electric current, or a combination of the orbit of an electron around an atom and the spin of electrons themselves, as in a permanent magnet. Activity 10.2. Aim. To prove that a magnet attracts iron and steel. Material required, a glass bowl containing common pins, a magnet. Method, bring the north pole of a magnet over a glass bowl containing common pins. You will notice that as soon as the magnet is brought over the bowl, the pins get pulled towards the magnet. Conclusion, this activity proved that a magnet exerts a force which pulls the pins towards itself. This force is the magnetic force. Activity 10.3. Aim. To prove that magnetic force can easily pass through wood or glass. Material required, a piece of iron pieces or nail, etc., a wood, cardboard or glass, and magnet. Method, place the iron pieces on the cardboard or glass top. Move the magnet under the cardboard or glass. You will see that iron pieces will follow the movement of the magnet. Conclusion, objects of iron or steel move towards the magnet due to force of magnet acted upon it, and this magnetic forces can be easily passed through wood or glass. Frictional force. Frictional force can be defined as the resistance to the movement of one body in relation to another body with which it is in contact. For example, if we try to slide a wooden block across a table, then friction acts in the opposite direction to the movement of the block. The amount of friction will depend upon the nature of the two surfaces in contact with each other. If both the block and the table are highly polished, smooth, then there will be less friction than if the surfaces were rough. Therefore, Friction always opposes the motion or attempted motion of one surface across another surface. Friction is dependent on the texture of both surfaces. Friction is also dependent on the amount of contact force pushing the two surfaces together. This gives us an idea about how friction works. If we try to slide one object over another, the irregularities in the surfaces of the two objects, their degree of roughness, causes resistance to the movement and we have friction. If we were rolling one object over another, the friction still arises because of imperfections in the surfaces. Friction then is a measure of the force pressing the two objects together. It is not, however, a fundamental force, as it originates from the electromagnetic forces and exchange force between atoms. In situations where the surfaces in contact are moving relative to each other, the friction between the two objects converts kinetic energy into heat, atomic vibrations. Friction between solid objects and fluids, gases or liquids, is called fluid friction. Friction is an extremely important force. It propels automobiles and other ground transport and holds nails, screws and nuts, along with many other uses. Coefficient of friction. The coefficient of friction is a dimensionless scalar value which describes the ratio of the force of friction between two bodies and the force pressing them together. The coefficient of friction depends on the materials used. For example, ice on metal has a low coefficient of friction. They slide past each other easily, while rubber on pavement has a high coefficient of friction. They do not slide past each other easily. Magnetically attractive surfaces can have very large friction coefficients, and glued or welded together surfaces have infinite friction coefficients. We can measure friction in terms of a coefficient of friction. This is the ratio of the force needed to move two objects in contact with one another and the force holding the two objects together. For example, if we have a block resting on a table with the table exerting an upward force of 20 N on the block and we need to apply a force of 5 N to move the block, then the coefficient of friction is 520 or 0.25. In terms of an equation for this we can write static friction force, Fs, equals coefficient of static friction times the force exerted on the object by the surface. So how could we reduce this level of friction? We could add a lubricant such as oil between the two surfaces or replace sliding with rolling. We can use ball bearings. This greatly reduces friction. Other ways include the use of air cushions, for example hovercrafts, and by streamlining car design, cyclists' helmets, etc. Angle of friction. Another measure of friction is the angle of friction. To measure this, we would place an object, say a block of wood, onto a surface and slowly tilt the surface until the block of wood started to move under gravity. By measure the angle of tilt we determine the angle of friction. Other forces. Biological or muscular force. We all need energy to do work. When we pull or push, lift, stretch or compress something, a force is needed. All the activities we perform in our daily life we need to have force. This force is exerted by the muscles of our body and is called muscular force. This muscular force is exerted by the contractions of muscles fiber. There are two types of fibers. The amount of each type of fiber one has is genetically predetermined. By exercising one type of fiber you can increase the size of that fiber over the other. Slow twitch fibers. The more slow twitch fibers one has, the better of an aerobic endurance they have for long endurance activities, like cross-country running. Fast twitch fibers. The more fast twitch fibers one has, the better one is at explosive activities which need bursts of energy, like basketball. Our muscular force has limitations. For works requiring bigger muscular force we either use more powerful animals or machines to provide the more force. Mechanical forces. The force generated with help of machines is called mechanical forces, but machine cannot generate Energy by itself. Some type of energy is required to run the machine. We supply energy which is converted into force which enables the machine to work. Examples are: petrol is used in motor cars, wind energy is used to produce wind force which is used on sailboats, grinding of various crops, water energy is used to produce electricity, energy of coal is used in engine. Units of measurement. You can possibly lift a bucket full of water but you cannot lift a big drum of water. How you define how much force you can exert the full bucket? You need to have a defined unit to measure force to answer this question. Let's answer this question. The unit for measuring the force is the kilogram force, kgf. The kilogram force is defined as the force required to lift an object with mass of 1 kilogram. Thus the force acting on 1 kilogram mass is 1 kgf. The Newton is the SI unit of force which is defined as the force that will give a mass of 1 kilogram and acceleration of 1 meter per second per second. 1 N equals 1 kilogram m/s2. The earlier CGS unit is the dyne. The Newton is obtained as a result of Newton's first law of motion. Force equals mass times acceleration. 1 Newton is that force which when applied to a mass of 1 kilogram imparts to it an acceleration of 1 meter/second. 2. Conversion factors between the other units of force and the Newton are: 1 pound force equals 4.448222 N. 1 kilogram force equals 9.80665 N, exactly. Thus 1 Newton is equal to the force required to lift 100 grams of mass vertically. Spring balance. A spring balance or spring scale is a weighing scale which is commonly used to weigh an object at home or at shops. The spring balance consists of a special good quality spring which is enclosed in a metal case. This metal case has a vertical slit on one side where the different weights are marked at equal appropriate distances. At the top end, spring is attached to the base of the metallic case and the lower end on the spring is attached to a metallic hook. At the base of the metallic hook where this is attached to the spring, there is a pointer attached. This pointer shows the zero mark at the rest. On the side of slit in the metallic case, a scale is engraved in gram force or kilogram force, kgf, depending upon the strength of the spring. Spring balance. How to use spring balance? The spring balance is a measuring device. The object which is to be weighed is attached to the hook of the spring balance and the spring balance is held vertically in the hand. The spring gets stretched due to the gravitational pull and hence the pointer moves on the engraved scale to show the weight of the object. Keywords: velocity, a quickness of motion; acceleration, a force that can make an object go faster; deceleration, a force that can make an object go slower; mass, the amount of matter in an object; magnetic field, it is the area around a magnet in which there is magnetic force. Summary: a force is defined as a push or pull that causes some kind of movement in an object. Force acting on an object will cause the object to change its velocity. Contact forces are types of forces in which the two interacting objects are physically contacting each other. Isaac Newton discovered that gravity is a force that acts at a distance and attracts bodies of matter toward each other. The force of gravity is dependent on the amount of mass a body has. The coefficient of friction is a dimensionless scalar value which describes the ratio of the force of friction between two bodies and the force pressing them together. One of the characteristic feature of magnets is that similarly charged poles repel and opposite charged poles attract. Frictional force can be defined as the resistance to the movement of one body in relation to another body with which it is in contact. A spring balance or spring scale is a weighing scale which is commonly used to weigh an object at home or at shops.